Today we're going to begin looking at diagonals, which is our fourth lesson from our unit on polygons. A diagonal is a segment that connects two non-consecutive vertices in a polygon. So again, that uses some kind of larger words that maybe we aren't real comfortable with, but you're talking about connecting a vertex, like this one here, with another vertex. Non-consecutive just means not in a row. So I can't connect, for example, this vertex with the one that's right next to it because I would be tracing right over top of the side of the polygon. And I can't do that. So it needs to be a vertex to a non-consecutive vertex. In other words, one that's not right next to it. So I could go from here to here. That would be a diagonal. Or I could go from here down to here. That would be another diagonal. But I can't go to this one because it's also a vertex that's right next to it. That would make a side of the shape instead of a diagonal. From any vertex, any one vertex in your polygon, you can draw in diagonals to the other vertices, obviously not the ones right next to it, as those would be the sides of the polygon. The number of diagonals that you can draw is 3 less than the number of vertices. And that's because you can't draw a diagonal from the vertex to itself, that's 1, or to the vertex to its left or to its right. So if you count that up, that's 3 vertices that you can't draw to. So it's the number of vertices minus 3. So here's an example of a 4-sided shape. So it has 4 vertices. 1, 2, 3, 4. So if I do 4 minus 3, I get 1. There's only one diagonal I can draw in from a particular vertex. So over here I chose this vertex. And I can draw in 3 vertices or 3 diagonals, one from here to here, here to here, and here to here. And 6 minus 3 is 3. And there are 3 diagonals. 8 minus 3 is 5, so we should have 5 diagonals here. If we count them up, we have 1, 2, 3, 4, and 5. So it's always the number of vertices minus 3 that tells us how many diagonals you can draw in from that particular vertex. How can you figure out how many diagonals you can draw in an entire polygon, not just from one particular vertex? Well, it is a little tricky. Because we know that from any one vertex, you can draw in n minus 3 diagonals. So over here on the left, these red diagonals, you can see, let's start with how many vertices there are. I'm going to start with that one. So 1, 2, 3, 4, 5, 6, 7, 8, 9 vertices. So 9 minus 3 is 6. So from this vertex, I should be able to draw in 6 diagonals. If we count those up, we see there are 6. But if I go to another vertex, like this one up here, and I want to draw in all of those diagonals, again, there's 9 vertices, I should be able to draw in 6. So if we count the green lines, we have 1, 2, 3, 4, 5, and then 6. But if you'll notice, you can kind of see right there next to it, there's a red diagonal and a green diagonal there together. And that's because that diagonal connects those 2 vertices. So we don't want to count it twice. There really is only one diagonal there, not 2 separate ones, so we don't want to count it twice. So we have to figure out a way that's going to account for that in our formula. So what we want to do is take the number of vertices, which is we're going to call n, and we're going to do n minus 3, which is how many vertices or how many diagonals you can draw from each vertex. We're going to times that by the number of vertices. So this would tell us how many lines we would draw in. And then we're going to divide that total by 2 because we have counted everything twice. So if we divide that by 2, that stops us from counting all of the diagonals a second time. So find the number of diagonals in each polygon. So a pentagon has 5 sides or 5 vertices. So 5 minus 3 would be 2. And 2 times 5 is 10. And then we're going to divide that in half. So there would be 5 diagonals. Remember, every time here we're doing n minus 3 times n. So in an octagon, there would be 8 vertices. So 8 minus 3 is 5. Times 8 is 40. And then 40 divided by 2 is 20. Oh, and this should say 10 right here. This is incorrect. Let me fix this particular slide because I don't want to give you the wrong information. I think I copied and pasted from the question above it. So that's no good. We want to make sure to fix that. So let's see, 10 minus 3 is 7, and 7 times 10 would be 70. And then we're going to take 70 divided by 2, and that answer would be 35. So there should be 35 diagonals. I think it might start me over. No, it didn't start me at the beginning. It kept me right where I was. Okay. So every time number of vertices minus 3 times the number of vertices, that answer divided by 2 to take away the doubles. How about drawing the diagonals? If someone asks you to draw in all of the diagonals, how do you go about doing that and making sure that you account for everything? Well, pick a vertex anywhere you want, and then draw in all of those diagonals. So I did this red one first. So I started here, and there's 6 vertices, and 6 minus 3 is 3. So I knew I should be able to draw in 3 diagonals. So I drew one here, here, and here. Then you move one vertex to the right. So I'm here in the blue, and you draw all of those diagonals. And there are 6 vertices, so 6 minus 3 is 3. I should be able to draw in 3 diagonals. So blue, blue, and blue. Then we're going to go one more vertex. Now, once you have left the 2 that were right next to each other, when you get to the next one, there should at least be one of the diagonals already drawn in there. That would be this red one right here. So we don't want to draw that one. It's already there. So draw in all of the remaining diagonals. So for me, that would be this one straight to the left, and then this one on the left angle. Then you go to the next vertex, and you do the same thing. So the blue one's already there, the red one's already there. There's only left for me to draw in this one yellow mustard color diagonal. When I come over here, I've got purple, blue, and red already there, so there are none for me to draw. And here I already have that yellow mustard, purple, and blue, so there are none for me to draw. And then we're right back where we started. You want to go all the way around your shape, making sure you're taking into account every one of the vertices. You can double check that by using both the formula and counting. So the formula, this is a hexagon, so 6 minus 3 is 3. 3 times 6 is 18. 18 divided by 2 is 9, so there should be 9 diagonals. And then from this vertex, I drew 3. Go around to the right, I drew 3. Here in this purple one, I only drew 2. In this mustard color, I only drew 1. And then at the last 2, I didn't draw anything at all. So I just add those up and find out I drew 9 diagonals. So you can feel free to double check yourself as you look at drawing your diagonals. The assignment today is going to ask you to do a little bit of each, counting how many there are and drawing them in as well. So please do your best and let me know if you have any questions.